Let's take another look at note number 112. So just pause the recording, go back and read note number 112, the fundamental theorem of calculus. Just exactly what does it mean in the first part of the fundamental theorem of calculus when it says the following? When it says g prime of x is equal to f of x. What does that mean? Well, in different notation, how would we write this in Leibniz notation? We would say, instead of saying g prime of x, we would express the derivative with respect to x, d dx of g of x is equal to f of x. Okay, well, let's substitute what we know. We know that g of x is defined to be equal to the integral from a to x, not 0 to x, but a to x of f of t dt. In this particular equation, we'll go ahead and substitute the integral from a to x of f of t dt. Then we'll get d dx of the integral from a to x f of t dt is equal to f of x. Yes, now it makes sense. Now if you just look at it and meditate on it for a minute, you'll see that what we actually have here is the fact that, okay, we're trying to say that the integral from a to x of f of t dt is the function whose derivative equals f. Once again, the integral from a to x f of t dt is the function whose derivative equals f. That sounds familiar. Aha. What does this mean? It means that the integral from a to x of f of t dt is actually the antiderivative of the function little f. That's right, ladies and gentlemen, antiderivative. And you thought we would never talk about that again. It seems like weeks since we've talked about finding antiderivatives. No, that was important. And it has come back now. It has come back now in the fundamental theorem of calculus. Here we see that this strange integral that has a variable in the upper limit, the integral from a to x, f of t dt, is actually the antiderivative of the little function little f.